Welcome everybody. My name is Sara Arias-de-Reyna and I am very glad to have the opportunity of introducing the paper called Tame Generalizations of GL2 over Q. This paper is a joint work with my PhD advisor, Professor Vila, and it is part of my PhD thesis. Let me begin by recalling one very captivating problem in number theory, namely the inverse Galois problem. Which finite groups do occur as Galois groups over Q? This is a question that any undergraduate with a basic knowledge in Galois theory may ask, and yet nowadays it is still a deep unsolved problem. Of course, due to the work of many mathematicians, there are lots of finite groups which are known to be realizable as Galois groups over Q. In our paper, we will concern ourselves with a variation of this problem. Namely, assume that a given finite group G can be realized as a Galois group over Q. Now we might ask ourselves about the existence of a Galois extension G over Q with Galois group G and also some ramification conditions. In particular, we will tackle a question posed by Gran and known as the Tame inverse Galois problem. Given a finite group G, is there a Tamely ramified Galois extension G over Q with Galois group G? This question has been answered affirmatively in some instances. For example, the symmetric groups, the alternating groups, some few groups, and so forth are all known to be realizable over Q with Tame ramification. In our paper, we will deal with the case G equal to GL2 where L is a prime number. These groups are long known to be realizable as Galois groups over Q. Our approach is based upon the study of the Galois representations attached to the torsion points of elliptic curves. Namely, let us take an elliptic curve E defined over Q, then the absolute Galois group of Q acts upon the group of the torsion points of E, giving rise to a Galois representation. By a well-known result of cell, this representation is surjective for almost all prime cell, provided that E doesn't have complex multiplication. The corresponding Galois extension K over Q will be then ramified if, for each prime P, the image of the well-initial group at P is trivial. In order to ensure this, we will take an elliptic curve which is semi-stable and also has supersingular production at L. Moreover, we have to ensure that the representation is surjective. For each prime number L, we give an explicit construction of infinitely many elliptic curves satisfying the conditions that I have just erased. In this way, we prove that the group GL2 occurs as Galois group over Q with Tame ramification. At the end of the paper, we have added some examples in order to illustrate our construction. Thank you very much for your attention and farewell.